cathode ray oscilloscope. In short form, we know it is known as CRO. Okay. So before starting the discussions about the CRO, so first we need to know what is the purpose of this CRO, means cathode ray oscilloscope, means where is it implemented. Okay. So in this chapter, means in these subjects, we are able to know that different types of measuring instruments. Okay, like different electrical electrical variables are there. Based on their electrical variables and their unit, we are going to measure the electrical variables. Okay, or in single, the in means simplifically, when we can say like that, where able to measure that electrical quantities like voltage, current, power, okay, energy. Okay, in all of them, okay, those are important. Means important means those are able to visualize. Okay, what are the nature of that signal. Okay, so visualize means you are able to see. Okay, previous discussion was based on that you are able to measure only the quantity. Okay, now if you want to see how their quantity, I mean how their nature. Okay, like in DC it's just you are getting just like a straight line, but what happened, okay, sometimes you are also getting some of the experiments that pulsating DC means ripple DC in single form, like that generator. Okay, like when the generation is there. Okay, DC generator. Okay, so if we consider only one winding, okay, you are getting only sinusoidal waveform. Okay, but what happened? It is not the fixed DC. For getting the fixed DC, you have to change the winding. Okay, there are two types of winding, like distributed winding, another one is lamped winding. Okay, so lamped winding means you are concentrated, all the windings are concentrated in single position, so you will get it's look like a sinusoidal but not exact sinusoidal. This is peaky type of sinusoidal, means it having unwanted harmonics. Okay, so fundamental component is sinusoidal, but you are getting unwanted harmonics. As well as for that distributed generations, okay, you are getting that exact sinusoidal. Okay, so that EMF generation is there in alternating EMF, so exact sinusoidal that is distributed throughout the space. Okay, so if you are able to measure the value, okay, so what happened in EMF meter, you are getting RMS value. Okay, so we are getting the RMS value, but if you want to visualize how they look like that, somehow distributed, one instrument having one machines having distributed winding, another machines having lump type of winding. Okay, so both the cases you are getting similar type of EMF, but you are not able to visualize how the EMFs are look like. Okay, so that's why the visualizations of the signal sometimes is very important, especially for that very sophisticated applications. Okay, like those are working on means power supplies. I'm just taking some examples. Okay, there are different zones are there, versatile applications are there. Okay, so if you don't know the means nature of the waveform, so the quality of the power you are not able to calculate. If you are not able to judge the quality of the power, so so there will be unwanted harmonics to the system. So you need to design the filter. The overall cost of the system will be. But how do you know everything? So only if you are able to see it, if you are able to visualize the signal. That is one point. Okay. Another important issue is there. It's not like only visualize the signal. You also measure the value. Okay. Like basically in cathode ray oscilloscope, so it's a measuring tool, okay, which having different scale. Okay, if you realize the diagram of that potentiometer where we are using some of the scale, okay, slider was there. Sometimes we are using linear slider, sometimes we are also using not slider, means sliding wire. Okay, sometimes we are also using that circular sliding wire. Okay, so we are changing their positions and changing their length. Okay, similar type of things also happen, but it is not length. Okay, you can change that vertical range. Okay, there is a pot. Okay, if normally that oscilloscopes are two channels. Okay, two channels oscilloscope. Okay, so normally what happened? Two axes are there. Okay, x-axis stands for your time duration and y-axis is stands for your amplitude values. Okay, so there is a one scale. Okay, means it's look like a pot. Okay, you can change their positions. So if you vary their positions, that means voltage per divisions. Okay, part divisions, unit part divisions in simple way. Okay, unit per divisions, if you are able to change the unit per divisions, automatically their range are varying. Okay, so if it is, so you are able to accommodate higher range of signal. Okay, higher range of signal inside of your, means in the display board of your oscilloscope, by reducing or by scaling down their range, scaling down their voltage ranges. Okay, it may be voltage, it may be current. Also you can able to amplify their ranges, means gaining factors are another important issue of the oscilloscope. There are, I mean, different types of, means different gain are there. Okay, so as per your measuring means procedure, you can step up that value, step down that value. As per stepping up and stepping down their value, we are able to accommodate all the signal in the window of your oscilloscope, means here. Okay, these all are the, means another features, means you are able to measure the value, visualize the value. Okay, if you go for that current means recent oscilloscope, now this means cathode ray oscilloscope is known as digital storage oscilloscope. Now all the oscilloscopes are having capability of storing the data. Okay, so if you are getting that scope, so you can also analysis. Okay, mathematical tools are also be there, like fast Fourier transformations, means FFT analysis, THD analysis, means mathematical tools also be there. Okay, so you have to purchase that mathematical tool and you can analysis your captured signal. Captured signal means storing the data. Data means not every instant. Some of the instant it is storing the values. Okay, after getting the value, you are able to calculate. Okay, there you are able to calculate the results. Okay, so these kinds of benefits you are able to, get by this oscilloscope. That's why oscilloscope is very important measuring tool in present scenario. Okay, everywhere you can also use. There are different types of oscilloscope: non-isolated oscilloscope, isolated oscilloscope. Okay, also there are probes are there. Probes means measuring wire of the oscilloscope. That probe having one positive terminal, another one is negative terminal. You are which component, if you want to make the measure the potential difference, so two terminals potential difference across a resistor or any other electrical quantity. So you have to connect the positive terminal one of that electrical quantity and negative terminal another that same electrical elements. Okay, then you are able to measure the potential drop across the elements. So negative terminal you are connecting over them, means you are virtually ground another terminal, means one of the terminal of the electrical elements. After that you are getting that signal. Okay, so in case of what happen if multi-channel, if I am telling like that by default there are two channels oscilloscope, means CRO are there, but current scenario we can also get 8-channel oscilloscope. Okay, that is very costly. But what happened for in normal oscilloscope? Okay, it may be cathode ray oscilloscope, analog as well as digital. Analog means conventional. Okay, here we are telling like that analog electronics means analog oscilloscope, analog measuring instrument means it is conventional. Okay, and digital storage, that is recent one. Okay, so don't be confused like that analog electronics, power electronics like that. No, don't be confused with your analog electronics. Okay, analog means in this subject it is conventional one. Okay, classical one means basic one. Okay, so in this analog oscilloscope, that by default there are two channels are there. Two channels mean at a moment you are able to measure two electrical quantities. Okay, but problem is there. I am telling that both the probes. Okay, both the measuring probes means it's measuring terminal. Probes is look like a wire. Okay, where having one side is connected to your oscilloscope, another portion is having two, means it is divided into two parts. Okay, one part is known as positive one, another part is known as negative one. So you have to connect if you want to measure the potential difference of an element. So positive terminal you are connecting, okay, of the element one terminal, and negative also portion also connected another terminal of the elements. Okay. But simultaneous, if you want to measure, basically there are another probe, okay, another channel. By default, I'm telling two channels oscilloscope. So if you connect same configuration with another components connected in your same circuit, then what happens? Okay, then problem is there. The negative terminal you are connecting with your one of the elements, okay, and same another negative terminal of your probe 2, okay, channel 2, you are connecting another terminal of your circuit. Then there is a huge problem to common ground problem. Okay, then huge current, circulating current will be flow in between two ground. So that may damage of your system. Okay, system as well as measuring instrument. If the current amount is high, so it can damage the fuse of your oscilloscope. Okay, that problems may arise. So simultaneously you cannot connect two ground of a oscilloscope in single circuit. Okay, for non-isolated channel oscilloscope. For isolated channel oscilloscope, what happened? Both the ground are isolated each other, so there will be no problem. But isolated channel oscilloscopes are very costly. So what we will do? We can use the differential probe. The probes are isolating the signals. Okay, the probes are isolating the signals. So there is a chances to implement that type of probe for simultaneous measurement of your system. So what are the most important topic of this oscilloscope? First one is that how it will be look like, and means how your play means how it is work. Okay. Then read instructions. Instructions is very important. So when you are working with some electrical or electronics instrument, first you need to about their spec. Spec means specifications. Spec. Okay, specifications you need to know. Means rating of that instrument. So how much maximum it can tolerate voltage value, current value. So power limitations. In single word, you have to know about the power limitations. Then frequency limitations. That power limitations, why it is so important? If you connect your that oscilloscope will cost huge, more than lakh. Okay, one oscilloscope is more than lakh. Okay, nominal cost is nearer to the 1 lakh. Okay, for Indian market. Okay, so if you go for the branded one, so it will be more than 3-4 lakh. Okay, so you have to means handle all the instruments very carefully. Basically, it's a very sophisticated instrument. So read the instruction carefully. So which voltage level you can able to give. Okay, current level, maximum means what will be their means features, means maximum means division per meter means division per unit actually. Okay, so all the things are very important. Break into small parts. Okay, so you can to remember to understand everything. So small part you can consider. Decide a simple measurement. Increase your level of difficulty. Record the pathway, how to get there, and source of direction. So by this way you are able to measure the electrical quantity by using the oscilloscope. Okay. Now another thing is that popular instrument, very popular instrument that can show time. Okay, voltage both DC and AC you are able to measure. So individual channel having you have to select that couple. Okay, is it DC coupled or AC coupled? Okay, three things are there: DC, AC. Another terminal is there that is called ground terminal. Okay, to checking the ground. Okay, where is your ground of that instrument? To find out the ground, you are selecting that ground terminal to see where is the ground. Basically, you are measuring the value means with the reference of your ground. Okay, and another thing, there is a one arrow symbol is there. Okay, by this arrow symbol, anybody can understand which one is the ground. Okay, and that color of the arrow signal will be the probe means channel color means there are 4 channels means 4 different colors are there. Okay, means four individual colors are there, as well as their ground color, then wavefront color will also be different, means based on their color combination. Okay, so what you are able to show, that voltage as well as time, both you are able to see. So display the waveforms. Okay, display the waveforms. Spectrum scope shows the voltage or frequency, means spectrum analysis I am telling. Okay, so whatever value you are able to get, so after that you are analyze that value. Okay, voltage automatically you will get from the waveform. Frequency you can calculate. Okay, so how much alterations are there, based on their alternations you are able to calculate. Also there is a measuring terminal. Okay, so measuring, you see there are measuring bars, so amplitude measurement as well as time measurement, both the measurement process are there. So you can fix up the target. So this duration to this duration, how much time are there. Okay, you are directly getting the time frame. After getting the time frame, you can easily measure that frequency. Okay, you can do the inversions of that time period directly, you are able to. Also they can calculate, okay, how much frequency is there. So recent years a lot of features are there. Okay, then cathode is heated. So basic fundamental thing, cathode ray tube means whatever cathode there, like that valve before modern physics. Okay, so the concept was very old. Okay, there will be electrodes. You are heating the electrodes, and from the electrodes the electrons flows or emits. Okay, emits towards the fluorescent skin. Fluorescent skin means the skin, that CRT. If you open the picture tube of your TV, okay, now all of us using LED TV in our home. But if you remember that now it is 2021, you are remembering around 2004. Okay, 2000, not 4 exactly, in 2000. Okay, I don't know that any of you shown that type of TV or not. Okay, so you can see that CRT tubes are there, means cathode ray tube. If you open that old one, so you can see there is a huge tube. Okay, the picture is there in my slide. I can show that picture. So what happened? There are electrodes. So positive plate is there in your display, means fluorescent skin. Okay, skin is positively charged, and the materials are there. Okay, that's materials are there. When the electrode beams, electron beams are means emitted to that skin, so automatically it is projected where the beams are touching, so their color is changing, so you can see their color. Okay, so how that electrons will getting the interest to come to that skin. So basically the skin is positively charged. Okay, the skin material is inherently positive, and you are heating, give the heating at that electrodes, so electrodes are emitting the electrons. Okay, and that emits the electrons and accelerate towards the fluorescent skin. In between of that path, okay, there are normally there are two vertical plates are there, as well as two horizontal plates are there. That is written over here, and that accelerating anode, that telling. So what are the important thing? Intensity grid, focus grid, accelerating anode, or electron guns, that I am coming. Before horizontal deflection plate, vertical deflection. After that I am telling of them. So electron beams are going. So what happened? So if it is look like that, so directly beams are coming. Okay, so what is the problem in the root? Okay, in that root, it having chance to somehow that there is a changes of that path electron. So what you need to do, you have to provide some bias voltage. Okay, so you have to provide some bias voltage to biasing the path of that electrons, path of that flow of electrons. Okay, so there are four plates, two are situated such a manner, you have to give the potential, two situated such a manner in vertical position, another two are there for the horizontal positions. Those are parallel to the horizontal position, so they can take part to vertical movement of the beam. Okay, electron beam. Those are situated just for a minute. So sorry. Okay. So so what happened that vertically positions. Okay, that those two plates are situated in horizontally. Okay, they can responsible for the movement of vertical movement of the electron beams. Means as per your bias voltage. Okay, whatever bias voltage you are providing, the deflections. Okay, so you are giving some of the bias voltage. So the electron beams are changing their positions, and you can see, you can visualize their displacement in your where in your the tube, sorry, in your display window. So how they are changing their positions, I'm taking just for example. Okay, if you want to change that voltage per division, there are two ports I am telling. One is voltage per divisions, or another one is time per divisions. Voltage means what? It can also measure the current. Okay, means in standard it is known as voltage per divisions, volt per divisions. Okay, so if you changing the scaling of that volt per divisions by the pot, so that bias voltage is responsible for what? Voltage is responsible for amplitude movement of your electron beam. Okay, so if you changing the voltage per divisions, so that horizontal, that I'm telling that horizontal plates are there, their bias voltage magnitude is changing. Based on their magnitude is changing, so what happened? The electron beams that I'm telling, that visualize that electron beam, their amplitude also changing. Okay, they're moving. Okay, if you change their scale, so they are moving. Okay, as well as there are some shifting options is there. You can vertically or horizontally move your signals. Okay, move your signal flow. Okay, so by the changing of that bias voltage, okay, you are able to shift their locations, means shift their positions, not location, shift their positions. That is important thing. Another thing is that vertical deflection plate. Similar thing happen. Vertical deflection plate means it can responsible for what? Vertically they have placed. They're responsible for movement of horizontal movement, means time per divisions. One, I am telling the time per divisions are there. So if you change the bias voltage of the vertical plate, so their time movement is changing. If their time movements are changing, so what happened? Time movements are changing means you can expand the time frame or you can make it concentrate. Okay, this the way you are able to change, or you are able to means vary their positions. Okay, vary their positions in that window. All of you getting my point? Then what is intensity grid? Intensity grid means intensity grid, focus grid, accelerating node, and focusing grid means what happened? Sometimes intensity grid means if you make more heating, if you are doing more heating, so more electron will be emitted. So then what happened? You can see line will be more thick. But problem is that focusing problem. So if the line is thick, so measurement, there is a error of that measurement. So that what you need to do, you have to focus the line. So they should be thin in nature. So how would you make the thin? So you can adjust the intensity grid, say intensity grid and focus grid. So they are trade off each other. So if you adjust them, so you can change their thickness. Okay, you can change their thickness, thin to thick or thick to thin. Okay, now all the electron beams are running in mode. Okay, all are in running in mode. So in analog oscilloscope you cannot stop them, but in digital oscilloscope what you want to do, you can stop the signal, means you can fetch at that instant how the signal is there, so you stop that one. So now after stopping the signal, you can observe how they look like there. Then how you can also do other mathematical calculations also. Accelerating anode means you can accelerate the electron flow. Okay, so if the intensity of that anode material is more, so electron will be come first to that plate. Okay, means to the skin. Okay, so that projected skin, you can see the electron is projected one side of the skin, and you are observing another side of the skin. Okay, so and you can see that response how they look like that. Okay, I hope you are able to understand basic points. Okay, so then what happened? When electrons hit the skin, okay, when electron hit the skin, the phosphor is excited. So we are using which material? Phosphor material. Okay, and emits the light. That white light, whitish light. Sometimes it is a green skin and yellow light is coming. Okay, normally green skin is there, yellow light is coming. Okay. Persistence, how long the display glow. Okay, how much time display glow is there. Okay, may need to reduce the ambient light for older instruments. So definitely, if aging effect is there, so the efficiency of that electron emitting quality will be reduced. So automatically they are in blunted in nature. Okay, connect a signal to the vertical plate. I hope all of you are able to understand why the signal will be connected with the vertical plate to bias that signal. Okay, you are moving, you are adjusting their positions. So who will responsible for adjustment? The means signal adjustment. So bias voltage. So x-axis you are giving bias voltage as well as y-axis you are giving the bias voltage. So vertical plates are there, vertical and horizontal plates are there. You are giving the bias voltage to them for adjustment their positions. Okay. At the same time, a voltage that increase linearly with time, that is ramp voltage, okay, that you are providing to apply the horizontal deflected plate. So for horizontal plate, what type of voltage you need to give? You are giving ramp voltage. Okay. So nature of the voltage is what type of? It is ramp in nature. Okay. You can see the ramp type of voltage. Okay. This is ramp up, then straight down means it is known as sawtooth. Okay. So this is ramp type of voltage and known as sawtooth. So horizontal deflect the producer sweep generator. Okay, so this is called sweep generator. So that voltage you are providing over there. Okay, voltage you are providing over there, that is called sweep generator, and they are in ramp in nature. Okay, now it's look like a sawtooth signal. Here you can see they are in sawtooth in nature. Okay, sawtooth. When the sweep signal returns to zero, okay, the return to zero, that means the end of the sweep, the beam flies back to the start positions. Okay. The beam is cut off during the flyback time. Flyback time means revert time. Revert means energy is flyback, normally known as, you know that flyback very common term for or hunting means machines in our generating station machines, as well as flyback converter means basically flyback means you see like that flywheel. Okay, flywheel, did you see? So that we know that sugar cane. Okay, we are extracting the juice from the sugar cane. Okay, roadside before corona, I hope all of you see that sugar cane are passing through a there is a rolling type of thing, two rolling bar are there. In between you are just providing the sugar cane, and beside of the sugar cane you can see big wheel are there. That is called flywheel, means exchange of that. So you are giving sometimes force to them, and rest of the portions additional energy is coming from that flywheel. Okay, flywheel means it can provide you the energy. Okay, so potential energy to kinetic energy to potential energy. So both of the energy means conversion is done over there. That flywheel concept is known as, in our electrical point of view, that is called flyback. Okay, so flyback means energy is one is incoming of the energy, and after that again it will be stored the energy. So same thing also happened over there. When beams will be back again start. Okay, so again it will be start position, then off position, then start position, then off positions, like that. So sweep, the shortwave wave is there. It is also known as sweep signal. Okay, or sweep generator. So that is responsible for shortwave generation, that works like a flyback. Okay, during the flyback time. Okay, so beam is flying back positions. Okay, if you remove that one, directly beam will be stopped. When if you are giving the energy, okay, that heating of the plate, so electron beam will be developed. Okay. Then important thing is that the display is appear stationary. Okay, basically you can see observe the display another side, and electron are emitted another side of that, that's in glass skin. Okay, this control by your adjustment setting. So how you are adjusted, based on that everything will be, every results will be shown to you. Okay, the I sees a waveform. Okay, x is horizontal, y is the vertical height of the trace. Means y stands for amplitude, x stands for time. Okay. Then the signal is amplified. Okay, the signal is amplified by the vertical amplifier applied in the vertical plate. So if you want to vertically amplification, so so vertical amplifier gain bias voltage should be changed. The positions of the vertical amplifier signal is applied by the sweep trigger. That sweep you are giving means ramp signal is there, that is called sweep trigger, that is given in vertical positions also. The sweep trigger generates a pulse coincide with the selected point, okay, in the cycle of the trigger signal. So based on your cycle means switching time period. So regular interval the same signal will be coming. Based on your switching time period, it is giving you the time, it is providing you to changing of that value. Okay, this pulse turns to the sweep generator initiating the sawtooth waveform. Okay, so you can see the sawtooth waveform. The sawtooth wave is amplified by the horizontal amplifier, okay, and applied to the horizontal deflection plane. So both the case you are able to see that bias voltage is coming in the form of that sweep signal or that ramp signal. Okay, you can provide the signal in the vertical axis as well as the horizontal axis or horizontal plane. Okay, so based on your selection, you can fix up the frequency 50 Hz. Okay, for Indian convention, if you use any other anywhere else, so you can fix 60 Hz. Okay, the provisions to make that external trigger. So here we are always telling about the internal trigger. So frequency will be selected by internally. Okay, whatever frequency you are selecting, frequency of what? Frequency of that ramp signal. Here you can see that sweep signals are there, ramp signal, sweep ramp signal. So you are fix up that frequency. So this frequency, okay, the duration is internally decided. Also you can give it externally. Okay, that additional port is there, that is known as Z axis. So for analog oscilloscope, backside it is given, not only analog oscilloscope, digital oscilloscope also it is given in the backside of the oscilloscope. So we are externally you are providing the trigger signal to there. So based on that signal you can get or sample your results. Okay. So most important functions of the CRT tube control. What are the most important functions? One is power button is there that you can on or off. On scale, what scales are there? Okay, so you can fix up the scale unit. Okay, illumination is important. Basically, that backside one light will be there. Otherwise, you are not able to see that electron beam. Okay, so illuminations of the oscilloscope is very important. Focusing terminal also be there. Create a spot on the skin. If their in intensity is more, so it will be thicker in nature. So focusing is very important. So how perfectly means electron beams are emitted to your phosphor skin, means phosphor skin. So it should be thin in nature. Also their intensity will be good. Otherwise you are not able to understand. Intensity means brightness. Okay, do not burn the spot on your skin. Okay, so do not burn means intensity is more means what happened, there is a not chances for the burn. Okay, they are actually telling to mean they are trying to tell you. So if the focus is more means intensity is more, focus is poor, then what happened, you are not able to understand the signal. Okay, they are very blunt in nature. So focusing also very important. So intensity should be good and focusing also very good. So it will be perfectly focus over there. Okay, you can see their glass. Okay, they are in concave in nature. Okay, so concave in nature. So focusing is very important. Where it will be focus. Okay, then vertical amplitude is there. So vertical positions of display. Okay, so if you change the vertically, so positions also of the display has been changed. Sensitivity of the vertical amplitude calibrated, called fully clockwise. Okay, so already your instrument is calibrated, okay, from by the manufacturer with some standard instrument. But still you can see how much calibrations are there. So one external source is there. Okay, so when you are when you are purchasing one oscilloscope, okay, they are inherently they are giving one terminal. Okay, that terminal, beside of the terminal it is written, it is something hertz. Okay, 2 volt peak to peak, and some hertz is mentioned. Okay, maybe 50 hertz. Okay, 50 hertz to 2 volt peak to peak. So if you connect your probe over there, So your oscilloscope, if your oscilloscope in factory setting, okay, so oscilloscope should give same voltage. You have to cross check that volt per division as well as time per division. So whatever voltage written over there, and your oscilloscope, after measuring the reading from your oscilloscope, you will get the same voltage and frequency. So you can assure that your oscilloscope is properly calibrated. Okay, so properly calibrated, there is no such problem. Okay, so for client confidence, they are also incorporating such terminal to understand how their calibration. Okay. So variable sensitivity, continuous range between the calibrated step. Okay. So why it is variable? Basically, you are not measuring only fixed value. So fixed range is you are going to measure. So that's why based on your fixed range, you are calibrating the signals. You are getting the signals. Okay. So AC, DC, ground. So three terminals are there. One of the probe. So you can measure if you want to measure that probe by using. If you want to use your probe for measuring AC components, so you have to fix up it AC. If you want to measure DC components, so you need to fix up in DC. And if you want to see where is your ground, means which reference you are going to measure, DC value or AC value, so fix it in ground. So you can understand where is your ground. Okay. The selects the desired coupling. So this is called the coupling. Okay. Desired coupling for incoming signals or ground amplitude input. Okay, DC couples signal directly to the amplitude. AC connects via a capacitor, blocks the DC. Okay, so if you are using AC, so DC will be blocked. If you are using DC, so AC will be blocked. Ground equal to no signal will be provided over here. So which one is your data or reference you are able to measure or find out. Ground connect Y input to 0 volt. Okay, so Y input to 0 volt means Y is your amplitude. Amplitude input you are giving 0 volt. Checking the positions of 0 volt as V scheme means that means both the plate you are giving 0 volt, and you need to see where exactly electron beam is emitted to your skin. By that you can easily understand which position is a ground terminal. Okay. Now horizontal sweep. Okay. So sweep time means how much divisions you are giving. Select the desired sweep rate. So volt per divisions or time per divisions. Okay. You have to select based on the sweep durations. You are able to based on the sweep duration, you are able to measure. Okay, so the signal for constant duration. So which duration you want to measure, and you are able to get the value. Okay, so admit the external size to horizontal amplitude. Okay, sweep time per centimeter variable with continuous variable sweep rates calculate fully clockwise. Okay, clockwise means it is also possible clockwise. Okay, so if you increase the rate, so you have to go clockwise. If you reduce the rate, you have to go, sorry, if you reduce the rate, you have to go clockwise. If you increase the rate, so you have to go anti-clockwise. Okay. Positions are needed. So positions of control of the horizontal positions of the trace. Horizontal variables are also needed. The control attenuations of the signal applied to the horizontal amplitude through external horizontal connector. Okay, so all the cases you are able to measure the horizontal sweep. By changing the sweep, you can measure the electrical quantity of your system. Okay, I hope all of you are able to understand. So, good. Then we are using the trigger. Trigger means that may be auto or normal. So why it is auto and normal means automatic you are giving the trigger signal to the plate. Okay, that by default it is provided by your oscilloscope. Okay, you are getting directly by default trigger signal as well as automated or means that is automatically coming, and normal means you are generating the trigger voltage externally. Okay, initially what happened, some of the studies are there. Okay, where you need to sample or where you need to initially what happened, if you can consider in 90s. Okay, in 90s there is no storage oscilloscope. Okay, there was storage oscilloscope, but it was very costly very costly. Okay, not cost effective. As well as in Indian culture means Indian scenario, that was quite means scarcity. Their presence is quite means very less presence you can see in the Indian market, as well as their storing capability was not so good. Okay, then those are working that time for data storage from the oscilloscope. What they are doing? They are externally designing some circuit. Okay, and they are giving the trigger pulse to them, means from the triggering terminal. Okay, and fetch the values from the results. Okay, they're directly collecting the data from the signal. Okay, and they're analyzing that based on the trigger value, how your x values are there, how is your y values are there. Okay, so if you normally what happened, we are taking the response in everywhere in time domain response we are taking, but in oscilloscope we are also able to take both the response. Means you can use one channel for voltage measurement, another channel for current measurement. So normally what happened, voltage measurement in terms of what, in terms of time, current measurement in terms of whom, in terms of time. Okay, but it also possible you are measuring the voltage in terms of current and vice versa. You are measuring the current in terms of voltage. Both the way you are possible, but that's why you have to select one mode, that is called XY mode. Okay, so your oscilloscope only that time your oscilloscope able to measure only the state variables. Okay, so in this case time will no matter. So both the cases time is fixed. Okay, in this case you are able to fetch the voltage and current value based on your trigger signal. So you have to fetch the data. Okay, so you have to, they are what they are doing, they are preparing on circuit, external circuit for the trigger signal. They're giving the trigger signal, okay, from external circuit, and sample the voltage and current value at that duration and collect the data. Okay, then they're analyzing the data. Okay, by that way they are doing their research or work. Okay, which measurement they are going to use for their research. Okay, so trigger select timing beginning of the horizontal sweep. So at that I'm telling, so when it will be start, when it will be off. Okay, if you give it externally, so it will be controlled by your own hand. Okay, so slope is what, slope is the select the trigger for the positive increase or negative decreasing. So ramp up, ramp down like that. Okay, coupling means whether the trigger set the specific DC or AC level, how much values are there. DC coupling, AC coupling, that I am telling. For DC coupling is there, so if DC is connected, how much values are there. Source is internal from the vertical amplifier, or external you can give from the external trigger input, that I am telling. And line means that time is there. Okay, that is 50 hertz or 60 hertz. Okay, by default. So you are able to give that trigger signal internally as well as externally. That's the motivations. So volt part divisions, okay, switch is there, means there's a pot type of things are there. If you change their position, so volt part divisions may be changed. So it can be 10 volt part divisions. If you change, you can change from 10 volt part division to 5 volt part division, 2 volt part division, 1 volt part division, 0.5 volt part divisions, 0.25 volt part divisions. Okay, also you can get 50 volt part division, 100 volt part division based on their sophisticacy of the instrument and the cost, means rating of that instrument. So range depends. Okay, range vary. Volt per division means amplitude range is varying. Time per division is okay. Okay, there is a how much accurately you are. If resolution is very accurate, means more accuracy is very good, so your bandwidth of the oscilloscope will be more. Okay, so normally in our lab we are using 70 megahertz. So if you get more bandwidth, so you have to go to 100 megahertz. Their costly is more than 5 to 8 lakh. Okay, so here we can see that volt part divisions are there. Okay, variable and fine adjustment, that focusing adjustment. This control can have a pull out switch positions, maybe 5 times in magnitude. Okay, so pull out switch means their magnitude can be changed, that I am telling. So amplitude or magnitude can be changed up to 5 times, but in present scenario you can change more than 5 times. Okay. Okay, that I'm telling. 100 volt part division also you can change, and there is a probe, there is a one gaining factor. It can also changing or scaling down 10 times. Okay, it can also scaling down 10 times, or you can amplify it about 10 times. Okay, everything, lot of things is possible. Okay, vertical modes are there. Okay, in the vertical mode, what happened? The operations of the vertical deflections plate. Okay, So channel 1 and channel 2, I am telling that by default 2 channels are there in oscilloscope, can each operate separately. Dual channel 1 and channel 2 are sweep alternatively, that both the channel 1 and channel 2 they are operate independently. Then you can operate both simultaneously, channel 1 and channel 2. That is called dual mode. Okay. Why dual? Used to measure the input and the output signal of the device under test condition. Okay. Channel 1 and channel 2 can also be added. Okay. But in dual mode of operation, the problem is there. If one probe 1 channel means probe 1 ground is connected to your system. So for channel 2, okay, that probe to ground should not be connected to your circuit. So if by mistake, if you are able to connect them and that oscilloscope is non-isolated type, so there is a high circulating current, so you are not getting the reading, and you can see that drastically everything has changed. Okay, so that's why isolation is very important, but isolated oscilloscope is very costly. Okay, or external isolation you can also do by using isolation transformer, that also be possible. Okay, so oscilloscope may be less, means costing is less, but you are preparing external isolations for making your oscilloscope efficient. Okay. So time base is there. Okay, here we can see the time base. Okay, main max. Okay, minimum delay, everything we can see over there. Select the sweep of the for the main mix or delay mode and also XY switch. Okay, so all the modes are possible. Okay, then time per divisions provides the selection of sweep rate. Okay, range of zero point 0.1 second, 50 to 1 millisecond. Okay, so 52.1 microsecond per divisions, that also be possible. Okay, determine the frequency from reciprocals of the time. It's simple. The frequency is 1 by time period, that is 50 Hz equal to 1 by 20 millisecond. Okay, time period equal to 1 by frequency. So number of division into millisecond per divisions. Example 4 divisions. Okay, into 5 millisecond per division. So 20 millisecond is the time durations. So what will be the frequency? 1 by 20 millisecond. So that is coming means alternating, repeating that value. So it is 50 Hz. 50 Hz means 20 millisecond. Okay. That I am telling about you the calibrating channel. Okay, calibrated voltage at there, 2 volt peak to peak, 1 kilohertz square. Okay, square voltage is given. So that terminal is there, that is called calibration test. Okay, that is called calibration test. So there are two terminal, one positive terminal, another one is ground terminal. So you are connecting your probe, okay, channel 1 or channel 2 in factory settings. Okay, without changing anything. Okay, you can select, you just you connect your positive terminal of the probe to the positive side and negative will be negative. So directly you can see, okay, directly you can see this is coming 2 volt peak to peak, means positive half plus 1 volt, negative half plus 1 volt, sorry, minus 1 volt. So plus 1 minus or minus 1, that means 2 volt peak to peak you are getting, and 1 kilohertz. You can calculate the time period, then reciprocal of the time period you can see that is coming 1 kilohertz. Okay, so allow the individual components to be tested. Okay, so individual component also be there that can be tested via the banana jacks test register, capacitor, diode, transistor, everything you are able to test. Ground is there, so earth terminal of the scope, directly you are able to connect the earth terminal, so that is called ground of the system. Okay, connections are there. What are the important connection? Vertical input, horizontal input, external trigger, and calibration output. Okay, so these all are the connections. Bandwidth of the oscilloscope that I am telling. So normally based on your bandwidth, the costing of the oscilloscope is decided. Okay, so if the bandwidth is more, so costing will be more. Okay, so 10 megahertz. Okay, 10 megahertz CRO does not mean it correctly measures signal at 10 megahertz. Okay, the vertical amplitude are not wide band, so the amplify the signal 10 megahertz is 3 dB points. Okay, a 10 megahertz one would measure up to 0.707 volt on the screen. So based on the bandwidth, you can fix up the range. Okay, so 10 megahertz means it doesn't mean it can measure up to 10 megahertz. That's the by myth, but externally, basically for normally what happens, so time period, so whatever values are there, okay, so there is a thumb rule that we can measure up to 1/5. Okay, up to 1/5, sometimes 1/3 of that value. Okay, basically there is some decay. Okay, so that's why you are not exactly getting that 10 megahertz. Okay, so clipping introduce the odd number of harmonics. The CR operate the maximum frequency, not only will not show the harmonics, and you think that you are reading the clean signal. So focusing and intensity is very important. And clean signal means that develop the harmonics for what? Harmonics may come for your system properties. That may be one reason for connecting the harmonics. Okay, coming of the harmonics. Another problem is there if your system is not properly tuned. So you will get hazy type of thing, distorted type of waveform. You are thinking like that you are getting the harmonics. If you mathematical analysis of doing those signals, so it can show there is a harmonic. So two reasons may be there, and there is a, you can see like that there is a thumb rule. Okay, so 5 times. Okay, to measure the 2 megahertz used for 10 megahertz CRO means 1/5 normally we are able to measure. Okay, if it is 10 megahertz means up to 2 megahertz. So 3 times is suitable for most amateur work. So 3 times also be there. So for 7 megahertz time means 21. So 20 megahertz oscilloscope is required. Okay. So this is by default some givens, values are given. Okay. So some of the other important things are there. Okay, I think in next class, so you can see the diagram of the oscilloscope. Okay, it is look like a oscilloscope. Okay, so these all are the analog oscilloscope. Okay, very old one. Okay, so here you can see it is 10 megahertz oscilloscope. Okay. This is cathode ray tube. Heating elements are there, so electron guns beams are coming, and it can reflect it over there. Okay. Some of the additional portions are there. Okay, so that we can discuss in my next class. Okay, so I hope all of you able to understand. So is there any class on